Hey guys, welcome back. This is Frank, and welcome to our IGCSE CoSci Physics revision videos. Our current unit is P4 Light and EM Spectrum. So, today's video is going to be our final video of the unit, which is going to be on uses and dangers of EM waves. So, in the last video, we talked about the electromagnetic spectrum and the different wavelengths in the spectrum. And today we're gonna talk about some of the applications and dangers and prevention to these dangers of EM waves. So, um, to begin with, let's just list out the waves and just list out their properties and their uses. So I'm gonna start with our wave with the longest wavelength, which is radio waves. So radio waves are usually used in uh, broadcasting and communications. Well, I mean, that's pretty straightforward considering the fact that it's called radio waves, and we use that on radios. It's for broadcasting and communications, and to kind of expand on that, we have multiple uses. For example, uh, yeah, the reason why we use radio waves for broadcasting communications is because it has a longer wavelength, which means which means that it can travel further in the atmosphere. This is good because we want, in order to be used in communications, we want it to like travel very far away. So if it can has a longer wavelength, it's gonna travel further, and it can also reflect off hills and the upper atmosphere. So yeah, like again, radio waves, if they can bounce off hills and bounce off atmosphere, that means uh you know we don't have to really worry about it not being able to pass through buildings and pass through hills and stuff like that. So it's really good for communications, and it enables you to enjoy entertainment anywhere in your cars. And yeah, that's about it for radio waves. Next up, we have the wave is the second longest wavelength, which is microwaves. So microwaves is usually used for, well, first of all, cooking food. We know that because most of us have a microwave. Uh, the microwave. We usually refer to microwave as like the machine itself, right? So it's used for cooking food, and it's also used for satellite transmissions actually, and I'll explain why in a second. Transmission. Okay, so satellite transmissions. Well, first of all, it can cook food because it can be. Oops, sorry. It can be absorbed by water molecules. So basically, what it does is that it helps vibrate and thus heat up the water molecules inside the food so that it evaporates, and and we're left with like very hot food. Yeah, and it's used for satellite transmissions because it can penetrate atmosphere. So you know like of course, if you want to communicate with satellite, it has to like go through the atmosphere, and microwave does exactly that. But unlike radio waves, there is actually a possible um, danger to microwaves, and I'll write it here. Danger is that possible. So it might, if you are exposed to a large amount of microwaves, you might your internal organs might be damaged by the heat, because well, apparently if it can vibrate water molecules, it might also be able to vibrate the the cells in your body. So it will cause your cells to heat up, and you don't want that. So yeah, possible heat damage to internal organs. Moving on, that's our second wave, and our third wave is infrared. And infrared is usually used to uh, is usually used in heaters. So we have infrared heaters and night vision equipment. So all right. So this is, first of all, it's used in heaters. Uh, well, I mean, it's used in heaters because it generates heat, because the energy the wave carries, and it's actually very common if you take a look at if you search up online like infrared heaters. They actually have those portable ones that you can put by your side, so that you don't feel so cold during winter. But yeah, the danger of it is also that if you expose to it for too long, you might get burned, and that's also actually also written on the product itself. I believe, like, if you buy an infrared heater, it will tell you that don't put it too close to your body, because otherwise you're gonna get burned. But anyway, we're gonna talk about that later. And the reason why it can be used for night vision equipment is because all objects gives out infrared. So it it's unlike visible light, which is not quite visible if it's dark. Infrared rays are given out even at night, so it can be detected by special equipment, night vision equipments, and it can be used to track where different things are, especially how in CSI shows and in police crime shows, they have police officers wearing those night vision equipment, and they can see where the suspect is, even if they're hiding in the woods, let's say, because they give out a lot of infrared uh, rays, and also a lot of heat, so special equipment can detect that. Anyway, it is also actually used in. I should probably write it up here. Actually, it is also used in your TV remote controls. So I'll just mention it here briefly. Uh, and oh, oops. So heaters, night vision equipment, and TV remote. All right, cool. So, just move this over here. All right. So heaters, night vision equipment, and TV remote. That's infrared. And as I've talked, as I've said, like, the danger to infrared rays is that you know you might get burned if you are exposed for too long. So skin burns. Anyway, moving on, we have visible light. Well, I mean, yeah, that's pretty self-explanatory, and there's nothing much to talk about that. But I guess the uses of visible light is just human vision, because well, we can only detect visible light. Photography. So yeah, well, you can't shoot anything that you can't see. So photography and optical fibers actually. Uh, Optical fibers. As we talked about in this unit, optical fibers use total internal reflection. So yeah, they actually also use visible light to carry information. And yeah, special thing about visible light is that it's the only part of the spectrum that is visible to humans. So you can our eyes cannot detect other rays, other kind of EM waves without like technology. So yeah, only part visible to humans. Like, you can't just go into the night and see infrared rays, because that's gonna be kind of creepy, and you're gonna be a superhero, something like that. Anyway, uh, Well, infrared. I mean, visible light doesn't really have like much danger, but I guess one thing you could talk about is that exposing to very bright light can cause eye damage. Well, that's why they tell you not to stare at the sun for too long, or I don't know. That's pretty common sense, I guess. So I don't need to explain that too much. Can cause eye damage. All right. So moving on, number five, we have ultraviolet. So ultraviolet is usually used well in fluorescent lamps. And so the special thing about ultraviolet is that uh, it can be absorbed uh, by special chemicals. So I'll just write it this way: absorbed by special chemicals, and which convert to visible light. So that's how all those UV lamps work. Like, when they check if a banknote is counterfeit, they just shine a UV light on it, and there's kind of these counterfeit properties characteristics they're gonna look about that are only visible under UV light. That's because there are special chemicals on the note on the notes on the paper. So when it's when it when you use a UV light to look at it, um, it can convert these UV rays into visible light. So some potential dangers about UV rays. I guess that's also what you hear about like the most when you go out. When say that's say you're going out to the beach and your parents might be warning you that you might get sunburnt because of UV rays and you have to apply sun creams. Those are also UV rays apparently, and they they do cause damage to your skin, and that's what we're going to talk about right now. So the dangers of UV light include eye damage, sunburn, and skin cancer. So people who expose under the sun for too long actually also, or without applying sunscreen, of course, also might it's actually bad for the skin, and don't do that because the amount of UV light is a lot. I'd say if you stay under the sun a lot. But anyway, moving on, we have X-rays. And well, as you might have heard, X-rays are used mainly in medical equipment. Uh, because it allows you to see internal structure. Uh, see internal structure, or specifically, it passes through body issues. Pass through body tissues, and it is absorbed by bones. So basically, the reason why X-rays allow you to see your bones is because it doesn't quite affect your body tissues, so it just passes right through it, but it gets absorbed by the bones. So you can see through your body tissues without seeing through your bones because it's absorbed. So yeah, that's why it's used for medical reasons. And the danger of X-ray, I guess, is uh, well, it kills cells apparently, uh, because it's a very high frequency, and it also may cause mutations and dangers in very extreme cases. Uh, sorry, mutations and cancers. So that's why when you go take X-ray images, you are usually required to wear protection, or usually the doctor wouldn't be or the operator wouldn't be like in the same room as you, because well, exposing to too much X-ray can lead to very severe effects, including cancers. So yeah, and finally, I might have to expand this page a bit, so bear with me for a second. All right, so we just finished talking about X-rays, and we're gonna move on to gamma rays. So gamma rays, well, they are mainly used in medical as well, but they're also used for sterilizing food. So the reason is because gamma ray is such a huge releases such a huge amount of energy because it's a very high frequency wave. It contains a lot. It can carry a lot of energy. So it kills cells, and I mean that's a good thing if it's used in the right way, because well, apparently if you use that, for example, to sterilize food, then you might get a very clean and germ-free food, I guess. And if it's used in medical equipment, it can be used to actually kill cancer cells. So yeah, that's one common treatment. But anyway, uh, the features of gamma rays is that it is highly penetrative and can kill. So it's not something that you would like to make contact with every day. Uh, so yeah, as I've said, the dangers are it kills cells, and it may also cause mutations in cancer actually. Because well, similar to X-rays, if used in the wrong way, it can cause mutations in the cells and thus cause cancer because you might accidentally generate cancer cells. And yeah, although gamma rays are used to actually cure cancer, the bad if you use it in a bad way, then it can actually cause cancer. So doctors have to be really really careful about that. So, moving on, I think the last thing we'd like to talk about is, it actually isn't specified specifically in the syllabus, but I did meet some problems that asked this. So, yeah, ways to the protect yourself from the dangers of the EM waves. I mean, the most probable answer, I mean, the most the dumbest answer that you might have thought of is I'll write it in another color. Just leave the room. Okay, I'll write a heading. So ways to protect. So ways to protect from EM waves. For first of all, leave the room. So this is especially if they ask you about X-rays and gamma rays, like for example, doctors and operators, as I've said, leave the room because they don't want to be exposed to a large amount of, well, it's probably not a large amount, but cumulatively speaking, it's gonna be like a lot at the end of the day. So yeah, leave the room and wear lead uh, apron. This is especially for X-rays, because well, this is like a common thing in the hospitals. Like they make you wear lead aprons when you are taking, especially like an X-ray that might penetrate vital organs, because they don't want to hurt you. So yeah. And as I've mentioned, another very important way, this is specifically for infrared, to block infrared, is applying sunscreen. So yeah, I mean, if you're going to a beach or going to somewhere where it's very sunny, like California, I don't know, please make sure that you put on sunscreens, because not doing so might cause skin cancer, and I don't know, might damage your cells. So don't do that. And Another thing I'd like to briefly mention is about microwaves. So, microwaves are actually, the microwaves in your houses, like the machines, are actually very safe because the microwaves that they release are usually contained in the metal box. So you don't really have to worry about like microwaves leaking everywhere unless you forgot to close the door, which is stupid because you can't even turn on the microwave without closing the door. So, yeah, just don't stress too much about using microwaves. As long as you're not exposed to like a huge, tremendous amount of microwaves, you should be fine. You should be more worried about X-rays and gamma rays though, because they have very high frequencies, and even like a small amount might cause fatal results. Anyway, so to sum up, today we talked about some uses and dangers of VM waves. This includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. And yeah, and as I've said, this is also the last video of the unit. So just a quick recap of the unit. We talked about in the beginning we talked about reflection, then refraction, TIR, conversion lenses, drawing lens diagrams, EM waves, and finally today's topic, which is uses and dangers of EM waves. So all of these notes would be available. I'll upload it somewhere and link it probably in the description. And I'll also update the description of the older videos to make sure that they contain the link. And you might, you hope you found that helpful. And next unit, I'm thinking of studying on chemistry unit or something. But yeah, something I'm studying right now. But yeah, just look forward to our next video, and I'll see you guys soon. See you guys in the next video. Bye.